In the name of God, the most gracious, the most merciful. Today, God willing, we will discuss the subject of blast-resistant buildings. As well, we will discuss how to calculate the loads on it, whether statically or dynamically. In this fourth lecture of the series, here we will talk about how to calculate the magnitude blast loads on the structure. The first step, as we said, is to determine the basic parameters that I will utilize. I will utilize two basic parameters, which are the TNT equivalency and the scale distance. First, I must know them. Let's see them together. Whether I will work with static or dynamic analysis, I must first know what my concept is. The concept is that I have a quantity of explosives with a weight called W. Its weight is called regardless the type of explosive material, either TNC4 or NFO, whatever its name is. The important thing is the weight of the detonated or exploded material. This weight is called W. It is far from the structure in terms of its distance. The distance is called standoff distance, symboled as R. So, standoff distance R and weight of detonated or exploded material W. These are the two most important parameters I have. Through these two parameters, I can get all the information that will lead me to the loads that will affect the structure in all directions that we saw in this drawing. The first thing I say is that I must have an ideal or reference material. I talk about it to be equivalent. Its name is equivalent material. The reference explosive material is TNT. So if I take TNT as a reference, the code of UFC will be recognized as a reference material so that design engineer don't get confused with it. Any other material I bring will have a heat of detonation that is more or less than it. The important thing is that I will assign it to it. So there is a reference material which is TNT, and I assign all other materials to it in terms of W of the used material divided by V of TNT. I consider the used material in detonation to be equivalent in terms of TNT weight, which is my reference. For example, if I have TNT, its heat of detonation is 4, and C4, its heat of detonation is 6. If I divide 6 by 4, its heat of detonation is 1.5. So C4 is equal to TNT 1000.5 in terms of heat of detonation. So this gives you the same weight ratio. Each 2 kg of C4 is equal to 3 K of TNT. So I have the heat of detonation, which is H over H. So if I divide H by H, I get the ratio that I multiplied W over C4. I get the W equivalent. As you know, it is very simple. As we see here, we will see it in a clear vision, and here we will see it in the form of a table. Let's compare the three materials, C4T and ANFO. You will find that this is my reference. My reference is 100 pounds, for example. Each 100 pounds of TNT is equal to 73 pounds of C4. And in front of it is 122 pounds of AFO. Now we know the difference between them in a clear vision. Let's see it in the form of a table. C4, which has a higher heat of detonation, is 5.86, while TNT has a lower heat of detonation. So we really need a larger quantity to get this. All these stories and the name of the material and not the name material are included in this table. Once you know the name of your heating material, you divide the heat by the heat. It is a very common name. And you multiply it by the W of the material that you are talking about. It gives you W equivalent of TNT. And then you enter the curves because all the curves are prepared based on the TNT charge properties. Now let's go back to the second topic, which is the second band. The second band is the distance standoff distance. What is standoff distance? It is the distance that the detonating material moves away from the face of the building. It moves away a distance called R. What is R? R is the distance measured by the meter from the center of the detonating material to the edge of the building or the edge of the face that will explode in front of it. It is called standoff distance. In order to work with all this, we will use curve with a certain value. We can get out of it and cut with all these curves and get the value of it. All these are the parameters that I need. Do you understand what I mean? Therefore, there must be a reference for me for all the materials at all dimensions. All the explosive materials at any distance from the building. I enter it from the horizontal axis. I go up and cut with all these values. I get all the corresponding values from the brochures that will fall on the building or the impulses that will happen. How is this? Let's see. The first thing is to get the distance Z. What is Z? It is a scaled distance. This is what remains on the horizontal axis. What is Z? Z is R, the distance from the CG to the face of the building. It is divided by the weight equivalent or 1/3. This step is the next one after the determination of equivalent TNT weight. I repeat, we got it with TNT. We got it as if the weight is TNT. So all the weights here are TNT, even if it is another material, I convert it to TNT. The second thing is to grow R, then divided by W to the power of 1/3 to get Z. This is called the scale distance law. It is called the scale distance law. What is it? I divide the distance of the detonating material by its weight to the power of 1/3. To simplify it for you more, suppose I have a detonating material that has a certain weight and another detonating material with 8 times in weight. Does it make sense that both may give the same effect on the building? I can tell you yes. When the first detonating material is at a distance of r, at the distance of 5 meters, for example, when the weight of the detonating material is at a distance of 10 meters, which is double the distance, pressure that comes to the building as a result of a detonating material of weight bu at a distance of r is equal to 8w of it at a distance of 2r. Do you understand what is the benefit of this is? In both cases, you will divide this by this. It will give you the same z. The z1 here is equal to z2. These two are equal to each other when I enter the chart. Is there a difference? There is no difference. I will go out with the same value here, and I will divide it with all the cargo. If there is no difference, I will give it 8 times, because this is at a distance of r, and this is at a distance of 2r. I want you to be clear, guys, that this z factor is very important. It is very important that I enter and get all my values in the 14 charts that we will see, according to her case. At the end of lecture 4, let me summarize what we said in the previous lectures again as written in gray. In the first lecture, we detailed a comparison between the blast load and wind and seismic on the other side. And then in the 2nd and 3rd lectures, we defined the basic types of explosions as well as addressed the blast design strategy in detail. From the first time we sit with the client until we get the building designed against the blast. And then we took the first step, we showed it in detail, which is how to start calculating the calculations on the structure. We took the first step only in it until now. Finally, in this lecture number 4, we started the first step in the blast load design. When we come to do the basic parameters, how do we get same basic parameters? What do we use in the curve? We learned in detail how to get the TNT equivalency, and also the scale distance. Then there is a subject that we will talk about in the next lecture, which is highlighted in the lower yellow, which is the unconfined explosion. This is what we will talk about in the next lecture. And this is the 14 curves that we talked about more than once. But for the subject written in brown, which I am talking about the confined explosion, in a building confined to the load inside. This, of course, leads to progressive failure and so on. So we will talk about how to avoid progressive failure or progressive collapse of any building or failure, how the building continues. This is something called robustness. We will talk about in detail. But the focus of our talk in the next lectures will be on the unconfined explosion. Thank you for participating in this session. Should you have any questions or feedback, please feel free to reach out to me via my Facebook page, LinkedIn profile, or by leaving a comment below this video on my YouTube channel. Best regards.